Good afternoon. It's a pleasure to be here. And again, I'm Matt Turek, Program Manager and now Acting Deputy Director for the Information Innovation Office at DARPA. And I'm going to tell you briefly about some of DARPA's investments in the trustworthy AI space. So DARPA's investments as an agency in AI go back a number of years, as illustrated by this chart. Oftentimes we think about the kickoff of the AI space in the 60s, and DARPA was an early funder of work in that space. Oftentimes that was symbolic AI work. So things like handcrafted knowledge. You could think about applications like TurboTax and how it uses rules to ensure that you're filling out tax forms appropriately. So over the years, there's been sort of a rise and fall in both the investment and in the capability of AI systems. But DARPA has been a continual investor in the space over a long period of time, dating back decades, obviously. So now we're into really the second wave of AI. So that tends to be statistical machine learning approaches. And those really took off with the advent of things like deep learning and AlexNet's application to computer vision problems like ImageNet. And again, you can see the breadth of DARPA investment leveraging statistical and second wave machine learning. And so now we're really focused on trying to both exploit second wave machine learning and invent the next generation of AI and machine learning techniques. Because there's a number of challenges around the underlying robustness, trustworthiness, et cetera, for AI and machine learning approaches. And as illustrated by the chart, there are programs where we're making core investments in the research technology, and there are programs where we're making investments in exploiting that technology for particular application areas. So I'm going to tell you about three programs in the space that's related to trustworthy AI, again, across DARPA. So the first is the Explainable AI program. So I'm actually the program manager for this effort. And the goal of the program was to build machine learning techniques that removed the opacity that was really present in things like state-of-the-art deep learning approaches. And doing that while maintaining a high level of learning performance, so things like prediction and classification accuracy. And all of that is really to support appropriate trust for end users. So if you look on the graphic on the left-hand side, it really illustrates that we've looked at the entirety of the process for building machine learning models. On the tomorrow portion, you'll see that we've highlighted new and modified learning processes. So this might be additional feedback to the training process to support generating explanations. It might be things like new loss functions. We've also built new, more explainable models. These might be models that are easier for a domain expert to trace through and understand, so remove the opacity that way. Or it might be models that produce an explanation themselves, targeting something like an end user. And really, there's an entire spectrum of users, from developers to operational users to policymakers and oversight people that need different types of explanations. One of the most important things I think that we worked on was this explanation interface. It's really a component that interacts with the user to provide those explanations and allows them to discover and understand what the model is doing. So a number of approaches were explored, things like creating more explainable proxy models, using deep learning to create explanations. Those are example approaches. We developed a number of techniques that we're really excited about, some of which were applied to things like medical image analysis and demonstrated the ability for radiologists to understand the model even better than they actually understand the conditions in the medical images themselves. Techniques for detecting and debugging poisoned machine learning classifiers, which is certainly an important topic of interest. and things like after-action review for AI systems to support ultimately things like policymakers and oversight of AI systems. So another key program in this space is GUARD. And so the goal of the GUARD program, and this program is run by Bruce Draper, who is a program manager in I2O, is to develop the theoretical foundations and defense frameworks, and importantly, new evaluation frameworks for understanding adversarial machine learning. So adversarial machine learning, that domain includes things like noise patterns that are added to images or videos that are added in an attempt to break or fool a downstream machine learning classifier. And so attacks can be inserted in a number of ways. They can be inserted in the training data. They can be inserted in the runtime system or in the sensor. And all of those are important attack vectors that need to be understood. It turns out that there's a lot of work going on in the research field, but the challenge here is that there's really a back and forth between advances in the adversarial exploitation and the defenses. And one of the things that we noted was that the metrics that were designed in the research community weren't as correlated with practical robustness considerations. So that was an area that we are particularly interested in. So the program is developing both theoretical and empirical metrics for evaluating adversarial ML in various threat scenarios, and trying to develop theoretical guarantees to provide bounds estimates on performance and how subject a particular machine learning classifier may be to adversarial attack. And so the purpose of this is to establish foundational tools and methodologies to add robustness against adversarial attack to machine learning algorithms. The final program that I'm going to mention briefly is Assured Autonomy. This is another program in the Information Innovation Office. Sandeep Nema is the program manager for that. And the goal of the program is to develop rigorous design and analysis techniques that support continual assurance of learning-enabled autonomous systems. So that learning-enabled is particularly important. These are systems that may evolve and learn over time via how they move through the world, the data that they acquire. And so this program is looking to exploit understanding of the physical embodiment of the system and the limits and how that system and how it may impact the machine learning algorithms, and just foundational approaches for characterizing things like deep networks and analyzing them from an assurance perspective. In particular, this program has focused on military vehicles and trying to add assurance to their performance and enable the use of machine learning algorithms in the context of things like control systems. So hopefully that gives you a flavor of the sorts of programs that we do at DARPA. These tend to be large, multi-year research investments. Each of those efforts that I highlighted tends to be a 3 or 4 year program with significant investments in a number of technical areas. Those sorts of programs are typically captured in a broad agency announcement. So that's how we provide information to the performer base and seek proposals for these particular topic areas. So if you're looking to get involved with DARPA research, you'll always want to keep an eye out for these broad agency announcements. Another mechanism for engaging is what we call AI exploration efforts, or AIEs. So these are meant to be targeted explorations of a particular AI technology area. And because they're focused on exploration, we tend to create these efforts rapidly. We have a rapid contracting process using other transactions to get industry and academic teams on contract. And these efforts typically last 18 months or so. They're much smaller than programs, but they're eventually meant to provide information about a particular technical area, and perhaps lead ultimately to a new program. And then finally, SBIRs. So DARPA has the ability and does create our own SBIR topics, phase ones and phase twos as well. And so there is an opportunity to engage with the agency via those mechanisms as well. So I would encourage you to look at sam.gov for specific opportunities. That is a good mechanism to understand announcements for BAEs, AIEs, and other opportunities to collaborate with DARPA. And with that, I will wrap up for today. Appreciate the opportunity to tell you a bit about the work that is happening in the AI space at DARPA.